All right, and then other items to consider. So wind, and not in the sense of the evapotranspiration that maybe additional wind would create, or more evapotranspiration, but in the sense of wind uplift and things that when you're talking about building design. And we only know one building in Portland that has had to do additional anchoring of the Ecoroof system due to wind uplift. It appears that a majority of the roofs that we visit don't have any additional kind of system to anchor that down at all. So I don't know if it's a major condition. Peter, is there anything you want to add to it? Okay, yeah.
Is that a flat roof that has
the anchoring system? I believe so.
It is, but this is what some of the people working on the project have said. So the final that went through the permitting process, we don't know for sure that they actually had to do something. They just stated that they thought they were going to have to do something. And it wasn't the city permitting process, it was their structural engineer that was saying something about it. So it's only come up once, and so the final, we don't know for sure that they did it.
We just wanted to acknowledge
it. But it did come up once, and we don't know why that project's any different than all the other ones that are out there that have been constructed for years. That are up on the roofs.
We talked about shade. Generally shade is a good thing. Many buildings have several roofs or penthouses, those things that will create that. And then also structures that are out there, PVs, solar water heaters, and trees can provide beneficial shade. Discussion a little bit about solar compatibility. And are Ecoroofs compatible with solar panels? Most of you know that yes, they are. And there's some studies out there that are showing that possibly solar panels are more efficient because they keep the solar panels cooler, and therefore they run at a more efficient rate. So we're showing here ideal slope for solar panels is about 32%. Slope, 90% is efficient, although still 90% efficient. Oh, at 22%. Boy, we got a lot of percentages there. Sounds high tech. So you can slope them lower if you need to, depending on if you have a building slope and you don't want to build a big frame or something like that. If your roof's already at, let's say, 22%, you can still put solar panels in there. Still 90% efficient is what we're saying there. If that clears it up at all, probably not. And so you can see in this example here that there's a frame that was built on a flat roof structure, and then an Ecoroof has been placed. It appears in maybe in trays underneath that system there. And then here's just another photo of these are solar hot water heaters that have the recirculating system. I keep trying to talk into the mic here. I've been asked to do so. So there's a PV that runs the pump that gets the water to move through this solar hot water heater. And then you can see the Ecoroof has just been installed. This one is just your typical soil and plant material, kind of your basic Ecoroof installed underneath here. You can see there is a pathway to maybe access these solar panels to check on them or maintain them, what have you. So that's just a nice example of that. And then also another example of a ballasted frame. So the Ecoroof is actually placed on top of this ballast here. So there's your maybe filter fabric, and then your panels are laid down here, and then the soil installed is being blown in right here, and then you have a more kind of typical just soil and plant material design there. So again, being very compatible, especially on a flat roof system. Yeah, question?
Do the solar panels affect the establishment and growth of the plants?
Yeah, well, I mean, in this example, like we talked about with shade and aspect, what we had, before the solar panels were going in on this project, it would just be a flat expanse, which then may require a little bit more irrigation. But now these solar panels, you can see here, are providing shade. And so maybe in these areas, there's going to be less irrigation that's required to get these plant materials growing. But as for specifics on the success of plant material underneath PVs and stuff like that, we don't know that yet.
Panels and the heat island effect of those guys.
Right, maybe there's some reflectivity coming down off of these guys or something like that. Yeah, that's a good question.
There is a German study. There's a German study that did monitor the plants and they did it for 5 years. And there was a transition from, they used one basic planting design, and then as the years went by, the plants did change relative to the shady portion to the sunny portion. And so the plants that liked the sun more did better there. The plants that liked the shade did better there. They had a mixture of about 10 sedums. And so then they found their place and then they adapted to it. So, and that was specifically, they wanted to answer that question. So the Germans have done a lot of research. It's just not very much of it's in English.
That's Tom's German interpretation of that report. I'm just kidding.
You mentioned that the green roof will keep, through evapotranspiration, will keep the solar panels cooler. Is there any study where you got that information that we could follow up with and look at?
I'm sure I can find it.
It's the same. It's another study by this group. This photo is in Germany, and they also studied that question. And it's not directly necessarily related to the evapotranspiration. It's the fact that the whole surface is cooler by evaporation and the other components that are associated with the planted area. So.
And here's just one more example of solar compatibility here, where we've got kind of a clear story design on a north side of a building, getting light into the building, then solar panels on the southern exposure, and then Ecoroof planted all throughout this in a tray system here. So they're not specifically or directly underneath the solar panels in this example, but nevertheless, all kind of passive solar as well as active PV panels as well as green roofs illustrated here.
Movable modules? Is that Ecoroof? Are those supposed to be modules?
Those are a tray system.
They would be movable, you think?
Yeah, you could definitely move them. Yeah.
And they're perforated on the bottom still?
We're going to get to those on Wednesday. Mm-hmm. But yes, they are trays, and they've got all kinds of things associated with them in there. How many do we have at last count?
8.
8 different companies. So you'll have your selection to figure out, okay, which one is the best for your project, if we even want to go that way. But,
right.
So we'll talk about it.
Right. So Tom, when he showed you that slide of the HVAC system leaking out across that Ecoroof, so we talked about air conditioning condensate that comes out. There's also washing sometimes of HVAC equipment, and then just maybe sometimes runoff from those things. So if there's a way to eliminate those, situate or locate them in a way that may or may not, or may lessen the impact of the Ecoroof, I think that'd be a good idea. Whether we can, it'd be nice to know that somebody designed an Ecoroof where they told the mechanical where they should put their stuff. That'd be kind of nice. And they exactly. That was the assumption. Yeah. Tom, can you talk a little bit? No, I need you to talk a little bit about the Mosaic example on building design.
Right. So this building, it got the FAR bonus, and on this particular site, it's over at 11th and Columbia, Southwest. And what's happened on this building is the entire building has had has had lots of problems with the construction. So it's actually in litigation, and it has been being litigated for the last couple years. And so this is one where the roof, somebody came in, so besides windows failing and other things that are falling, I shouldn't say falling apart, but other problems, the Ecoroof also has had problems, and they did have a leak in the building, not caused by the plants or the roots, but caused by somebody that supposedly changed something from the original design and said, oh, it would be better if we did this instead of this, and then something about that malfunctioned. And so it's just one where this is sort of the first, as we got into this idea of encouraging people to do Ecoroofs, there was always this sort of nervousness that, well, someday something's going to happen and one's going to fail, there's going to be a problem, and then what do we do? And it might be the end of the whole idea, right? So we have had a number of problems, and we're still going, and it's just kind of, whenever human beings build something, something goes wrong. So whether it's an Ecoroof or a building or a car or something, everything has its lifespan and its potential problems. So anyway, so this has had, this project has had that. And what was interesting is that this one was, because it was in litigation, nobody took care of the roof because everybody was kind of like in this, you know, the, what do you call it, the paranoia of the legal system. So nobody would do much. So we went up there about a year and a half ago, and most of the sedum was alive, even though it hadn't been cared for about 3 or 4 years.
It didn't know about the litigation.
Right, yeah. It decided to keep growing.
It hadn't jumped yet from the roof.
But anyway, so this is just one, you know, a problem. We've had some other lessons as we're going to.
And then I think the other one we just wanted to touch on was the Ecotrust building. And I think the one, what we just want to say about this particular one is that it struggled, the plant material struggled because of the slope of the roof was nil or flat and actually kind of went up and down in places, and so water would pond just ever so slightly in lower portions of the roof, and therefore the plant material really struggled because it was wet for long periods of time. So just want to acknowledge this one in the sense of learning as we go. It's important to have positive drainage. It doesn't need to be excessive drainage, but just positive drainage, and being sure that the failure isn't attributed necessarily to the Ecoroof specifically, but building design had a major effect on the performance of this Ecoroof.
I just want to add really quick that the soil composition was a huge problem, exacerbating that as well.
Right. Yeah. In the sense of a heavier soil.
And maybe even heavier.
Right. Didn't promote drainage either. So. Yeah, there were, yeah, right. Thank you. There's
on the Mosaic, I mean, it seemed like they had about 1 million penetrations through the Mosaic. It's every single component, the electrical penetrations, the mechanical penetrations. In design, if you look at all those mechanical units, they were, you know, you got to make sure that you really accommodate those so that you're not, first of all, the Ecoroof would be a lot easier to install and function a lot better, but they actually had all the mechanical units blocking the drainage. And so the positive drainage, that was part of the problem with, I think, the leaks is, you know, they, besides other errors, but they didn't make it any easier in design.
Right, so if you can avoid, so the take-home from that is if you can avoid all this stuff, because there's more than you can see in this picture, well, if you do this, you're just, whether you have an Ecoroof or not, every one of those penetrations and vertical elements is a potential problem for a leak.
Concentrated to a mechanical room.
In any kind of roof.
Something there.
So on an Ecoroof, it's even,
that's a good point.
More of a problem.
Yeah.
Could you backtrack over the comment you made about the soil on the Ecotrust problem and how it contributed to the cooling problem? I didn't quite catch how that worked.
The soil, well, the soil that was put in way back in 2001, the design originally came from a company from Germany, and so they had this certain way that you do things. Well, that certain way of doing things of their system required a porous soil, which is basically what most people are using now. This soil was developed by a landscape contractor and a person that was right out of college that, and you know, this is right at the beginning of when we're doing these, and nobody really knows about this stuff, and the German company didn't tell anybody, so they put together a very high compost, high organic soil mix, and it had to be 2 inches or maximum 12 pounds, I think, something like that. So they came up with the soil, and then that soil just has not worked. The drainage problems, the flat portions of the roof, the water's sitting there, it's higher organic matter, the soil's holding it back. So the two main problems on that I know of is the soil and the problems with the structure itself. That it doesn't, in some places, it does not have any slope to get the drainage out. And then the water accumulates there because the soil's so porous.
And it's held, right, by the soil.
It's held there and it stays there for like 4 or 5 months sometimes.
Once it starts raining. There's
Once-
a puddle from the last rainstorm a week ago.
Right, so I think you're the person that's maintaining it, right?
Yeah.
So details about Ecotrust, you can check those out.
The last thing.
What about putting in plants that are tolerant of wet feet?
That was done in 2004. They put in a lot of plants that could take wet feet, and they worked for a while and then they died. And it was a kind of a person that's an expert at wetland plants that can survive in dry conditions. So anyway, yeah, there's a lot to try and figure out.
It's a good segue into the next photo, where here, this is where Tom and I are going to segue, but this is where we're going to talk a little bit about membranes. But here's a wetland on a roof. So needless to say, they had to definitely take into consideration some waterproofing of this building. All right.
And this is just right down the block. So it must be permittable. Actually, it's down the block in Germany.
Right.
It's not.
Just a little ways away.